Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell and today we're going to be talking about solving inequalities using multiplication and division. Let's jump in. First of all, I want to take a minute to talk about the multiplication properties with inequalities, and we'll start with positive numbers. Okay, this property tells us that if each side of an inequality, sorry, I got a little off there. If each side of an inequality is multiplied by the same positive number, the sense of the inequality stays the same. Or essentially what it's telling us is that the inequality symbol does not change. Let's take a look at what I mean by that. If A is greater than B and C is greater than 0, then A times C will be greater than B times C. If A is greater than or equal to B and C is greater than or equal to 0, then A times C, and C is greater than 0, then A times C is greater than or equal to B times C. And the same is true of the less than symbol and the less than or equal to symbol. That is with positive numbers. Now, negative numbers, when we're multiplying, we talked about in the last video, it's a little bit different. Let's take a look. This property tells us that if each side of an inequality is multiplied by the same negative number, the sense of the inequality changes, and the inequality symbol must be reversed. Let's take a look. If A is greater than B and D is less than 0, when I say D is less than 0, I'm essentially talking about a negative number. And D is less than 0, then A times D will be less than B times D. Do you see how my inequality symbol shifted here? It turned in the opposite direction. And we always do that when we are multiplying by a negative number for all the signs. Same with greater than or equal to, same with less than, and same with less than or equal to. Okay, so here's an example. If K is greater than M, we're going to start with that. So what the multiplication property of inequalities basically tells us is that if K is greater than M, then K times 3, and we have M times 3 over here, what symbol do you think would go in between those two? Well, it's actually pretty simple. Of course, yes, it's going to be the same because K times 3 will be greater than M times 3 because, as we said in the beginning, K is greater than M. So let's look at how we solve inequalities using multiplication. It's basically the same thing as when we're solving an equation with inequalities. We want to isolate the variable and solve. And we use the inverse operations when we're trying to find the variable. So this problem asks 1 is greater than x over 2, which is telling us to divide. And so the inverse operation of division would be multiplication. So I'm going to multiply both sides of the inequality by this 2. And I've written it as 2 over 1. Okay. Now my 1's will cancel out. So basically 2, I've got the 2 here, and x over 1, I've got the x here. So now I have 2 is less than x. Now let's talk about the division property of inequality, starting with positive numbers. The division property of inequality states that if each side of an inequality is divided by the same positive number, the sense of the inequality stays the same. That is, that the inequality symbol does not change. So, written out, if A is greater than B and C is greater than 0, then A divided by C will be greater than B divided by C. And if A is greater than or equal to B and C is greater than 0, then A divided by C will still be greater than or equal to B divided by C. And the same is true for less than and less than or equal to signs. And now we'll talk about the negative numbers. Same thing with multiplication. When we're dividing by a negative number in inequalities, we're going to switch that symbol to go to the opposite direction. So as it's like formally written out, if each side of an inequality is divided by the same negative number, the sense of the inequality changes and the inequality symbol must be reversed. So if A is greater than B and D is less than 0, again, negative number, then A divided by D will be less than, not greater than, B divided by D. Same thing is true for greater than or equal to. That would need to become less than or equal to. So we're always going to move the arrow pointing in the opposite direction when we're multiplying or dividing by a negative number. Let's take a look. If I have, why this is true. If I have negative 2 is less than 2, true statement, correct? Okay. if I am asked to divide both sides by -1, I'm going to divide the -2 by -1, and I'm going to divide the +2 by -1. I'm dividing by a negative number. Watch what happens. -2 divided by -1, negative divided by a negative is a positive. Okay, so -2 divided by -1 is 2. And 2 divided by -1 is -2. If I don't switch that symbol, this statement says, or this inequality says, 2 is less than -2. Is that correct? No, we need to switch the symbol. That's why we need to switch the inequality symbol when we're dividing by a negative number. Same with multiplication. So if I switch it, now that makes sense. 2 is greater than -2. Now that is correct. All right, let's do a problem with inequalities that involve division. -3n is greater than or equal to 12. The opposite of multiplication is division, so we're going to divide both sides by -3. The 3's cancel out, as I've done here, and I have n is greater than or equal to -3. But I forgot, I've got to switch this symbol. And that is correct. N is less than or equal to -4. And once again, I just want to remind you, always switch the symbol when you're multiplying or dividing by a negative number. All right, everyone, that just about wraps it up for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.